MXRoad Suite Bundle is a unique bundle of interoperable softwares which includes MXRoad Suite, LeapBridge, StatPro, and Bentley Navigator. Today's road design projects demand design, analysis, and review tools that contribute to better, faster, and more cost-effective project delivery. These projects involve several interdependent engineering disciplines: roadway design, bridge design, and structural design. Each discipline requires a specialist software to carry out design. At the same time, the software needs to be interoperable to save time on exchanging information, thus avoiding costly errors and project delays. So in such a situation, how can MXRoad Suite Bundle help? Use MXRoad Suite for roadway design, use LeapBridge for bridge design, use StatPro for structural analysis and design, and use Bentley Navigator for dynamic review and analysis. At the same time, all these softwares are interoperable. Now let's consider a scenario where NH58 two-lane bypass needs to be constructed on DBFOT basis. The bypass will connect the hill on the other side through a bridge. The project will involve road design, bridge design, and this being a DBFOT project, it will involve the structural design of toll booth. Let's look at how MXRoad Suite Bundle 4-in-1 helps you to carry out the design work more efficiently through interoperability of the software. Let's first look at the workflow for MXRoad. Data can be imported in a variety of formats such as total station, dumpy level CAD drawings, but for this example we are going to use the Google Earth data and use it as a terrain model. Thus the first step will be to geo-enable the drawing and choose the proper UTM zone, which is zone 44 in this case, which corresponds to the Dev Prayag region. Once the zone is selected, click on Capture Google Earth Terrain and click on the screen. Data sits in the drawing on exact coordinates. The next step is to design center line, which we have already created and saved it in a text format. So import the alignment file, propose centerline.txt. We have also converted the Google Earth data into triangulation model using mxkeyIn command. The next step will be to create a scheme and place a pavement template on the alignment using Roadway Designer. So click on Load Roadway Designer, create a new scheme with the name MX Scheme 1. Add the alignment, propose road DP, which was created in the previous step. Add surface, which is Google Earth Tria as the existing surface. Next, corridors are defined where road section occurs, leaving apart bridge chain edges. Two corridors are defined. First corridor will start from 0 to 734, which is the start of the bridge, and second corridor will start from 961, which is end of the bridge, to the end of the alignment. Target button allows you to do the selection directly from the graphics. MXRoad already has ready-made cross-section templates which can be edited as per project requirement and can be placed on top of alignment using template drop option. You can then select the respective changes where the 2-lane and the 4-lane templates are to be applied. Transitions can be enabled while road width varies. You can then navigate through plan and cross-sectional changes and see how cut and fill are applied and process it. Last step in the design process is to create a 3D surface using create surface command. You can create one consolidated surface for both the corridors. As you can see, surface has been created. The next step will be to share the alignment and the ground information with the bridge engineer. Export alignment and ground data in land XML format so that it can be used by the bridge engineer to put his bridge into the project. So you can see project alignment.xml, which is shared with the bridge engineer. The next step will be to perform bridge design in Lee Bridge using geometric information exported from MXRoad. Let's look at how to do bridge design in Lee Bridge. Input all the project information on the first screen. Modeling is done in Automatic Bridge Creator. Import the land XML file exported from MXRoad suite. This is project_alignment.xml. This will pull in all the information related to alignment and profile into the software. Horizontal alignment information gets populated. Set the begin bridge chainage, which is 734 in our case. You can see profile information also gets populated. Choose the superstructure type, which is PSC boxes. Input the number of spans and the span length. Input all the cross-sectional information. Go to the substructure, choose the substructure type, which is hammerhead in this case, on piles. Input all the dimensions related to substructure. Input concrete strength and bearing dimensions. That completes your bridge modeling. It's a quick 3-step process. Click on geometry to see the model of the bridge. Click to import the terrain information, which is obtained from MXRoad, project_ground XML. Click connect, OK. Click here to see the terrain displayed in the model. You can see the alignment also displayed in the model by clicking here. Lee Bridge gives you an option to change the abutments to pier using a module called GeoMath. Save the file. Proposed bridge.xml. You can see using GeoMath, abutments have been changed to pier. The next step will be to export this model into a DGN format, which is a drawing format in MicroStation. The proposed bridge. Now let's see how toll booth is analyzed and designed using STAAD.Pro. Start the project. Choose the working units, meters and kilonewtons. Start the project by adding nodes which are obtained from MXRoad to get the exact location of the toll booth. Add the slab using plate elements. To get more accurate results, let's mesh the slab. The next step will be to add columns to complete the modeling. Next, we can start by adding the material sectional properties of the elements and members. Use the section database to assign steel sections to the members and define depth of the slab using the thickness option. Once we have selected and defined the properties, we can assign them to the respective members and elements. Moving on, we can add supports and loadings onto the structure as shown. Insert the design command. Perform the analysis. Having done that, you can run the analysis engine by using Ctrl F5 using the analyze option in the menu bar. When the analysis is complete, we can switch over to the post-processing mode to view the results in graphical and tabular formats, and also go through the output file to study the design results. Finally, we export this model using the ISM option in .dgn format so that we can later work on in MXRoad, and the toll booth exactly fits at the desired location as the coordinates were obtained from MXRoad. The next step will be to see how these three models are interoperable with each other. Open the MXRoad environment. This is the road design in MXRoad suite, and this is the desired bridge location as shown. Let's attach the proposed bridge.dgn, which was exported from Lee Bridge, and you can see the bridge exactly fits at the desired location. That's the desired toll booth location, and attach mytollplaza.dgn, and you can see the toll booth exactly fits at the desired location. So the drawing model exported from Lee Bridge and StarPro integrated well with MXRoad suite. Next step will be to publish an iModel feature available in MXRoad suite for dynamic review and analysis in Bentley Navigator. So name of the model is devprayag.i.dgn. Let's see how Bentley Navigator is used to do dynamic project review and analysis. Thus the iModel open in Navigator for review. Walkthrough can be easily created in Navigator. That's the road design in MXRoad. That is the bridge designed in Leap. You can do a very detailed walkthrough of the complete project so that if there are any comments from the reviewer, you can mark it out. The procedure for the markup is as shown here. Click on the markup dialog box and the markup dialog box will open, and click the location where you want to insert the comment. So here please check the transition length, and you can see it's inserted where the road changes from 2-lane to 4-lane. Also you have a markup status dialog box so that the correct roadway designer gets the drawing to correct it, and who did the markup or the review can also be mentioned. You can also print the PDF, and the PDF can be emailed or printed to correct the drawing. Let's see how the integrated model will be exported to Google Earth. You can create a KMZ file, an option available in MXRoad, and the KMZ file is then imported to Google Earth, and the integrated model fits exactly at the right location. You can have a street view, and you can see how well the model has fit onto the Google Earth. So it's a great viewing tool to get the feel of the project. "3D animation" is another great tool available in MXRoad, where you can actually animate your design created using MXRoad, LeapBridge and StatPro. You can actually put the moving cars onto the project and animate it and get the feel of the project. We believe all the softwares included in the MXRoad Suite bundle, MXRoad Suite, LeapBridge, Bentley Navigator and StatPro, will be useful to you and is a complete solution for your road project. At the same time, they are interoperable. We appreciate and thank you for watching the video.